Hello students, welcome. This is class 7 science, chapter number 14, electric current and its effects. It is lecture number 7. Topics to be covered. In this video lecture, we will be discussing the following topics, starting with number 1, energy labeling system. Number 2, ISI Mark. Number 3, magnetic effect of electric current. Then the solution of homework given to you in lecture number 6. And finally, the homework questions based on this lecture number 7. Let's start our today's class with the first topic, energy labeling system. What is energy labeling system? Energy labeling system for refrigerators, tabular fluorescent lamps and air conditioners in India has been launched by the Bureau of Energy Efficiency, that is abbreviated as BEE. You can have a look at the introduction of energy efficiency rating and labeling of this EE label. In this label, you can find few stars. These are also known as the energy rating. It ranges from 1 to 5 star. At the center, inside the star, the energy rating equal to the number of star is mentioned. Rest all details about the product are also mentioned for the proper understanding of the customers. Here, in some of the electrical appliances, you can find the EE label. You can check it on the washing machine, air conditioner, and even on refrigerator. Let's go and find it out in the appliances installed at our houses. This bureau is responsible for the improvement of energy efficiency through various regulatory and promotional instructions. Commonly, energy labeling is known as star rating. The BEE label displayed on a product indicates its energy efficiency. The label has a rectangular base and a semicircular top with 5 stars numbered 1 to 5 and indicator on the semicircular top shows that star rating the product has earned. Students, this is the star rating. It clearly indicates that more star means more saving. This is the energy saving guide for a customer while purchasing the electronic devices. From next time, whenever you will accompany your parents for buying electrical appliances, be careful about the efficiency of the device. The next topic is ISI Mark. While buying an electrical device, all appliances such as bulbs, tubes, CFLs, fuses, MCB, we should check it for ISI mark of the Bureau of Indian Standards. This mark ensures the safety and saving of energy by the device. This is the ISI mark. It is issued by the Bureau of Indian Standards. You can see the ISI mark on some of the common household devices and appliances. For example, on an immersion rod, sometimes even on the pressure cooker and on the geyser. Moving on to the next topic, magnetic effect of electric current. Magnetic effect of electric current. Students, it may sound astonishing to begin with, but it is true that electric current has a magnetic effect too. We already performed one activity to know about the magnetic effect of electric current. It was activity number 6, described in detail in lecture number 2 of pre-text activities. Let us now find the setup. As we all can see, there should be a source of energy. We can take any, a cell, a battery, or an electrical generator. Now, with the help of connecting wires, we have completed the circuit. In between, there is a lamp or a bulb. The most important part is the insulated copper wire, which is a straight wire made up of copper. Just near to it, you all can see a compass is placed. One important point to note here is that the magnetic needle of the compass is at rest and we have placed the insulated copper wire parallel to it. While performing this activity, we observed that as soon as the current flew in the circuit, the needle showed deflection. It means it started changing its direction. Yes, on turning the circuit off, the compass needle gets back into its original direction. It is the same direction which we started with. Hence, it can be concluded that the magnetic behavior of electric current was observed while performing this activity. Students, in that activity, when the circuit was switched on, the compass needle showed deflection, and when it was switched off, the needle goes back to its normal position without any deflection. It again went into the rest position. Now, let's summarize. This is because when an electric current is passed in a conductor, it develops a magnetic field around it and behave like a magnet. Thus, the phenomenon of developing of a magnetic field around a conductor on passing electricity through it is called magnetic effect of electricity. Once again, the phenomenon of developing of magnetic field around a conductor on passing electricity through it is called magnetic effect of electricity. The combined effect of electricity and magnetism is called electromagnetism. You can check here carefully. Electromagnetism has both the words electro taken from electricity and magnetism from the word magnetism. Hence, wherever we learn or discuss about electromagnetism, it already includes both the effects, the electrical as well as magnetic. Let us now discuss few important terms which are related to the magnetic effect. The first term is magnetic field. It is the area around a temporary or permanent magnet where magnetic force is effective. The area around a magnet where we can feel its attraction or repulsion is known as the magnetic field. You can check here in the diagram. The second important term is solenoid. Solenoid is a cylindrical coil of wire acting as a magnet when carrying electric current. You can check here that it is a coil of a wire. It will act as a magnet when electric current will pass through it. In this topic, let's discuss some of the applications of electromagnetism in electromagnet. An electromagnet is a solenoid with a soft iron core. The arrangement behaves as a magnet when an electric current is passed through it. You can now relate what is a solenoid? Yes, it is a coil of wire, and inside that cylindrical coil, a soft iron rod is passed. So this arrangement will behave as a magnet when current will pass through it. An electromagnet consists of an insulated copper wire coiled around a soft iron bar. When current is passed through the coil, the whole system behaves like a magnet. Its magnetism disappears as soon as the current through the coil is switched off. Therefore, an electromagnet is a temporary magnet. Students, pay attention to this. An electromagnet is a temporary magnet when we have formed a solenoid with the help of insulated copper wire coiled around an soft iron bar. Along with the current, the magnetism can also be switched off or on depending upon the shape of iron core. An electromagnet can be either a bar magnet or a U-shaped electromagnet. Let us now discuss the solution of homework based on lecture number 6, starting with fill in the blanks. Number 1. The fuse is called the safety device of an electric circuit. Number 2. The condition when the live wire gets in contact with the neutral wire is called short circuiting or short circuit. Let's now check the correct option for multiple choice questions. Question number 3. A metal which is used as fuse wire is. The correct answer is option D, tin. Some of the students may be considering option A, copper. However, let me remind you, fuse wire is made up of either tin or an alloy of tin and copper. So, alone copper cannot be the correct answer. The correct answer is option D, tin. Question number 4. Miniature circuit breaker can be abbreviated as. Yes, option A, MCB. Now, it's the homework time. Students, these questions will be based on lecture 7. Fill in the blanks. Question number 1. The area around the magnet where its force can be felt is dash. Number 2. The energy labeling is also known as dash. Further, we have multiple choice questions. Question number 3. The combined effect of electricity and magnetism is called. Option A, magnetic effect. Option B, heating effect. Option C, solenoid. Option D, electromagnetism. The last question, question number 4. Energy labeling system is launched by. Option A, ISI, option B, BEE, option C, MCB, option D, CFL. Be very careful while selecting the most appropriate option. That's all for this video lecture. Thank you.